All right. Unit 2. Key learning points of Unit 2. We're going to look at microbiology. We're going to look at the cycle of transmission and method of transmission. We're going to look at the causes of foodborne illness. We're going to look at controlling sources of food contamination. We're going to look at the two basic types of biological foodborne illness. And we're going to look at how to break the links. So the cycle of transmission is this triangle here. So there's 3 different places where things can be transmitted. So everything ends up being transmitted to the food because that's what makes us sick. And the food handler and environment are the 2 things that can either transmit back and forth to each other or will be transmitted to the food. So on a food handler, different bacterias or viruses can be contained on their skin, their nose, hair, hands, and clothing. And anything that has touched those pieces of the food handler that then touches the food is at risk of contaminating the food and making someone sick. In the environment, work surfaces, utensils, insects, and the air are all different places where contamination can begin. These bits of contamination can either be transmitted directly to the food or can be transmitted to the food handler, which can then transmit it to the food. So the direct transmission of bacteria an example would be this person using a finger that has a wound on it that is obviously infected. Now this wound is not covered properly with a glove, so therefore anything that this person touches, even if they're not touching with that piece of their finger specifically, could be contaminated with the bacteria. So this method of direct transmission is one that is easily avoidable by wearing a glove and making sure that any cuts or scrapes are cleaned properly, covered with a Band-Aid, and then having a glove worn on top. So for direct transmission, the microbes move directly onto the food. There's no middleman. So the 3 pictures that we have here, this one at the top, this lady has sneezed, and the microbes that she has sneezed have landed directly on top of the apple. This means that that apple now has any of those microbes growing on it and could potentially make someone else sick. This picture of the seafood down here is a picture where the seafood has been removed from an unsafe source. That means that the source is not undergoing any government controls and could potentially harbor dangerous bacteria. This is easily avoidable by making sure that you purchase all of your food and necessary items from proper sources. And finally, this picture over here, the raw meat is being stored on top of the produce that is not going to be cooked. Therefore, the juices that have now leaked down onto it are causing harm to the person who may eat them, because that bacteria will not be killed and the people who eat could get very, very sick. Okay, so indirect transmission is something that you can think of like cross-contamination. So the microbes don't move directly to the food. The microbes move from their original source to a secondary object, so the surface, utensils, or your hands, and then they move to the food. So in the top example here, the cutting board was originally used to cut chicken. The cutting board was not sterilized, therefore the chicken microbes were still on the board. Then the sandwich was put on, which means any microbes that are still alive on the board are now transferred onto the sandwich. And because the sandwich isn't going to be cooked, those microbes won't have a chance to be killed. The second picture right here Someone used a knife to spread some peanut butter. They didn't clean that knife properly, and then they used the knife to cut a tomato. So a person may ask in a restaurant if something they're eating has peanuts in it, and the item itself may not have any peanuts in it, but because this cross-contamination occurred, now their tomatoes have peanuts on it, which means that person could now have a deadly allergic reaction to the tomato. And finally, this picture here, the person pet his or her cat and now went to get ice cream. So we all know that cats aren't necessarily the cleanest of beasts, and now any microbes that were on the cat's skin are now on that person's hand and then cross-contaminated over to the ice cream that he's going to share with his friends. So a real-life cross-contamination case. Raw chicken. 14 people became ill with Campylobacter jejuni from lettuce cross-contaminated with raw chicken after eating in a restaurant. The cook reported preparing a salad on the same countertop previously used for cutting raw chicken without sanitizing between uses. So the cook did not take the proper precautions to make sure that his customers were kept safe. He did not clean that surface, so the microbes from the chicken were then transferred to the lettuce. There are three main causes for foodborne illness. So the first cause is biological. So in a biological cause, we're looking at bacteria, viruses, parasites, protozoa, or fungi. And we can call all of these together pathogens. So pathogens are simply all of those things grouped together that can cause illness. Chemical causes are cleaning agents, pesticides, or dissolved metals. So cleaning agents can sometimes be mistaken for food if they're not stored properly. They can be left on a container that hasn't been cleaned properly. Same with pesticides. If produce isn't cleaned properly, or dissolved metals happens when food is exposed to metal. This mainly occurs or can occur when cans are dented. So the inside of a can has a coating of plastic, but as soon as you dent that can, the plastic coating is now compromised, which means the metal is now exposed to whatever food is in the can. And if that food has any amount of acid in it, it's going to start eating away at the metal, and that dissolved metal is going to enter the food, which will then be consumed. And then there are physical sources of foodborne illness, such as glass, wood splinters, toothpicks, hair, bandages, insect parts, and metal particles. Now, not all of these things are going to cause illness right away. Sometimes they may be ingested and cause issues later on when they're being digested. Sometimes they can just make someone go squeamish, like a piece of hair. No one likes eating hair. So, biological causes. We looked at those 5 different pathogens that can cause biological foodborne illness: viruses, parasites, bacteria, protozoa, and fungi. But those 5 groups can then be broken down into 2 different kinds of biological causes. So we have foodborne intoxication and foodborne infection. So foodborne intoxication is when the bacteria has grown and multiplied and left behind a toxic waste. This toxic waste won't be killed off in the oven when it's heated, but will enter the person who ingests it and make them sick. foodborne infection is when the bacteria is ingested and the bacteria can make someone sick. So salmonella, you ingest the salmonella bacteria, it grows in your gut and you can get sick. The multiplying of bacteria. So every 20 minutes, bacteria will double. So if we start with one bacteria, in 20 minutes there'll be 2. In 40 minutes there'll be 4. In an hour there'll be 8. In 2 hours there'll be 64. And in 8 hours, 20 minutes, there'll be more than 33 million bacteria. So bacteria multiply when they're in the danger zone. And the next slide we'll talk about the danger zone. So in that danger zone, bacteria are healthy and happy and they want to grow, and they're going to grow as quickly as they can. They're going to create as many of themselves as they can. So this means any food that is left in the danger zone is going to have bacteria double very, very quickly and could potentially make someone very, very sick. If you're ever unsure of food that has been left, you're not sure how long it's been left out, you should throw it out, because there are many people who could be very sensitive to small numbers of bacteria, and it's not worth them getting sick. So the danger zone there is between the temperatures of 4 degrees Celsius and 60 degrees Celsius. So those in there are the temperatures where bacteria can grow and multiply very, very quickly. So you want to make sure that if you're holding food at any temperature for any length of time, that you're holding it at 60 degrees Celsius. That is the temperature where bacteria will cease to grow. At 74 degrees Celsius, bacteria will be killed off. And then boiling, all the bacteria will be killed off. Spores and toxins may still survive, and we'll talk a little bit more about spores and toxins later, but the bacteria themselves will have died. At 4 degrees Celsius, so that's the temperature of your refrigerator, bacteria will survive but will not multiply quickly. So this is why we keep our food in the refrigerator at 4 degrees Celsius, because it's less likely to spoil as quickly as it would on the countertop. At 0 degrees Celsius, things start freezing. Bacteria will survive but won't grow. At negative 18 degrees Celsius, that is where food should be stored in the freezer, just to make sure everything is stored and frozen. So vacuum package. Vacuum packaging keeps out oxygen, which is one very important tool for bacteria to grow. If it doesn't have enough oxygen, it's not going to grow as quickly. So that's the reason why a lot of meats and such are vacuum packaged, just to keep them fresher for longer. This doesn't mean that bacteria won't grow or pathogens won't grow. It just means that they won't grow as quickly as they could somewhere else. Though vacuum packaging keeps bacteria away, it may not keep things like botulism away. So botulism is something that uses a spore, and a spore can still make you sick. So in this example, the raw potato has been in contact with the inactive spores. The spores are a pathogen's way of protecting itself. So if the pathogen feels like it's going to get hurt, it will turn into a spore, and a spore cannot be killed. It's a very, very hard little organism. So the spore is now in the potato. The potato is cooked properly, but the spore is still going to survive, simply because you cannot kill off a spore. The potato then is left in the danger zone, And now that spore feels comfortable enough to come out of hiding, and it starts to grow and create more toxins. When that potato is then eaten, someone becomes sick with a foodborne intoxication. So a real-life case of the botulism bacteria, baked potatoes wrapped in foil were stored at room temperature for 18 hours before they were used in a dip. 30 people who ate the dips at the restaurant developed botulism. So another real-life case of bottled oil. Several people became ill from eating eggplants bottled in oil. Inadequate heating to destroy the botulism spores, along with other conditions such as the absence of oxygen, neutral pH, and high moisture content, probably contributed to the outbreaks. So the pH scale. Foods that are between 0 and 4.5 on the pH scale, meaning that they're an acidic food, are less likely to become contaminated with bacteria, simply because the bacteria does not grow well at pHs below 4.5. Foods that are between the 4.5 in that neutral zone are going to be potentially hazardous because their pH is not high enough to stop bacteria growth. Different places that food contamination can come from. So, water. Your water sources you believe to be clean, but if the restaurant isn't using the correct equipment, then the backflow could potentially come back into your restaurant, which could make people sick. Other sources are microbes. We need to make sure that we keep things washed, we avoid cross-contamination, and we can prevent growth from cooling, freezing, and cooking. And then other sources of contamination include utensils and equipment. We need to make sure that we're handling those properly and washing our hands, making sure everything is clean and all of these sources are kept to a minimum. So this is just a quick picture of a backflow preventer. So the water comes in from the public water system, and it's just kept so that the water cannot flow back from the public system after it's left the restaurant, which could potentially make people sick. Okay, a real case, egg safety. 28 people who attended a catered wedding reception reported a gastrointestinal illness identified as salmonellosis. The Caesar salad dressing was prepared with raw eggs. It was held unrefrigerated at the caterers for 2 hours and then placed in an unrefrigerated van until served at the reception several hours later. So being held at room temperature and then in the unrefrigerated van are two areas that the temperature is right in that danger zone. So the danger zone has now allowed all that bacteria to grow and multiply. And in the several hours, it could have multiplied to several million bacteria, which made several people sick. So food intoxication, we kind of talked about. So food intoxication occurs when bacteria grows and the toxin is released. The toxin is not killed in the cooking process. The bacteria may be killed, but the toxin is still there. The toxin then is ingested and is what causes people their illnesses. Symptoms of foodborne intoxication are nausea and vomiting, and some sources of this specific food intoxication, the Staphylococcus, are from people. So the Staphylococcus' main source is people, so from cuts, boils, scrapes, burns, pimples, noses, and throats. So this is why we need to make sure that anytime we cut ourselves, we wash our hands. Anytime you touch your face, you wash your hands, just to make sure that that Staphylococcus bacteria doesn't get transferred to a place where it can grow and multiply and leave the food intoxication behind and make people sick. Okay, and a food infection example, Salmonella. So in a food infection, people eat the food and then that has been contaminated with the bacteria, and then the bacteria continue to multiply in the body and cause the infection, cause people to become sick. So the bacteria grows in the food and continues to grow in the gastrointestinal tract. Symptoms of Salmonella are cramps and diarrhea, and the main sources of Salmonella are poultry, so chicken, turkey, ducks, and eggs, and other sources of animal food. So chemical causes of food, cleaning agents, pesticides, and dissolved metals. So cleaning agents must be labeled properly. You have to make sure that you know what you're using and that you're not grabbing something incorrectly. This is part of WHMIS, and if you've taken WHMIS, you know that all chemicals need to have their proper identification on them to make sure that they're being used properly. And then dissolved metals we talked about. They can come from cans that have been damaged and other sources. Okay, a real case of pesticide poisoning. Shortly after eating homemade foods at a company lunch, several people developed neurological and gastrointestinal symptoms. The person who had prepared the cabbage thought he was adding pepper from a can labeled black pepper. The can came from his relative who had used it to hold pesticides. So this is an example of improper labeling causing a lot of people to become sick. Okay, and then improper storage, metal corrosion. Students attending home economics classes reported illness included headaches, chills, dizziness, nausea, and vomiting after drinking fruit punch. The mixture had been stored overnight in metal-lined containers with very large areas of corrosion. Analysis showed elevated levels of zinc and iron. So once a can has been opened, you shouldn't leave food to be stored in it. That can is only meant to store the food when it's closed, and if you store food that's been opened in the can, it could potentially cause people to become very ill. Okay, and the final area of foodborne illness that we looked at were physical causes. So glass, wood splinters, toothpicks, hair, bandages, insect parts, and metal particles. So these are things that we just have to be very careful to not get into the food. So insect parts are sometimes unavoidable, simply because of where you get your produce from. But things like glass, if a glass breaks anywhere near something you're cooking, you always need to make sure that you throw out whatever you were cooking, simply because you don't know if a little piece of glass jumped in. Wood splinters and toothpicks, you need to be sure that if you use toothpicks to cook something, that you remove them, or that they're very easily noted in the food, so with a flag on the top or something cute like that, so that the customer knows to pull it out before they eat. Hair, we need to make sure that our hair is pulled back or in a hairnet when we're cooking. Bandages need to be kept under gloves so that they don't fall into the food. So real case physical contamination, a toothpick hazard. A man developed abdominal pain after eating a restaurant meal. Surgery 19 days later determined that a toothpick had perforated his bowel. A forensic examination concluded that the toothpick had been heated in the food, and the court determined that the food was consumed at the restaurant. The man received over $50,000 from the restaurant. So this is simply that the person who was cooking the food didn't remember to remove that toothpick, and the toothpick somehow ended up being eaten by this man. So the biggest thing that we need to do for Food Safe is we need to break the links between the 3 different areas where food contamination happens. We need to make sure that our environment is clean, that ourselves are clean, and that we're not contaminating the food, which could lead to someone becoming very sick. So you need to avoid contamination. You may think that your hands are clean, but this picture demonstrates how your hands simply are not clean unless you've washed them. We need to make sure that we're not getting people sick.